Hi, this is Kevin, and welcome to my tutorial on Zelle Chapter 6, and this is going to be for exercise 3, even though my code up here seems to say 2 accidentally. And this is a custom example. If you remember, we don't really like the ones that are in the book that much. So first thing I'm going to do is I'm going to change my comment up here to say that I'm in, name of my file is tutorial for exercise 3.py. Here's the skill that we're trying to demonstrate. We want to demonstrate that functions cannot change the original value of non-mutable variables passed to them as a parameter. Okay, parameter. That's misspelled down here. Okay. Now, I just want to point out that this is imprecise talk. Okay, because in Python, variables are just really labels. Okay, and they don't really have a type. Okay, and they are not really objects. They are labels that are associated with objects. You typically associate them with an assignment statement. And it's really objects that are either mutable or non-mutable, changeable or non-changeable. We usually don't call them non-mutable. We call them immutable. Immutable, 2 M's. Okay? So what we're really talking about is a variable that's been assigned an object that is of a type that is immutable. Okay, and we want to say, well, we can pass that, use that variable name to pass that as a parameter to a function call. And there's really nothing that the function can do to mess up the value that's seen in the calling code. Okay? We can clobber it in the called code, and it'll still be pristine in the calling code. Okay? So the example we're going to do, we're going to pass an integer object. So integer objects, float objects, string objects. These are 3 objects that we know of that are immutable. Okay. So if we pass a parameter that's pointing to an integer object, we shouldn't be able to change that value down in the called code. Okay. Let's demonstrate that to ourselves. So again, we're going to do the polite version of this. So we're going to put it into a main, def main. Okay. And then we're going to want to have a call to main down here. So we're going to have a call to main. All right. So we have all that stuff. Now we have to put some code in the main, or we get this indent expected thing. Okay. So let's create a variable called original int _int, and let's say it's going to get a value of 25. Okay. Okay. And then let's just print original int. Original int. Okay, and let's run a test. We print original int, and it's equal to 25. So that's the behavior that we're used to. So what we're trying to explore is it possible to use original int, that variable name, as an actual parameter on a method call, and have that method screw up the value? Can it change the value? Well, I'm saying not, but let's go prove that. Okay, so let's create another method Okay. And I'm going to call it try your best to change this. Okay? And then we have to have, if we're passing a parameter, we need a formal parameter name. Okay, and so let's call this my int. So this is going to be the name by which that passed int value is known in the function. Okay, so let's do this. Let's print in subfunction. Okay, and then let's say let's print original value is, and let's call it my int. Okay, because that's how you have to refer to it here. Again, could we use the name original int? No, it's not in scope. Well, let's just prove that to ourselves. Original int, it's going to light up as an error because the scope of things that we define in main are only known in main. Okay, it is some kind of a call to the function that it is going to match up original int with my int. Okay, so let's go back down here and undo that change. So now we're back to my int. Okay, so the original value is my int. And then let's just say my int, let's assign the value 99. Okay. And then let's say, let's print here. Copy. Let's say terminal value is my int, and I'm assuming that that's going to do what we want. And then so instead of in subfunction, let's call this enter subfunction. So we've entered the subfunction. Okay, and let's copy that and clone it into leave subfunction. Okay. Okay. So and then let's even use different names for it. So instead of calling this the original value down in the subfunction, let's call it my int value. My int value is that, and then we're going to say terminal my int value is that. Okay, and then up here when we say original value, let's say original value is, and then this. Okay. Okay, so we're still not calling this code. It's still just kind of sitting down there. So let's do a little testing. Okay, so let's run this. So it just says original value is 25. Okay. Now we're going to have to call this. Try your best to change this. So let's do that. Let's call try your best to change this. And what are we going to pass? Well, we're going to pass the original int. Okay. So now the question is, will that value be changed? I've claimed that because this is an immutable object, okay, And because we have our own reference to it up here, and that when we pass it as a parameter, an actual parameter, in a call to try your best to change this, we don't actually pass this variable reference. We pass a copy. Okay, so in Python, when we pass the parameters, we don't pass the actual original variable references. We pass a copy of them. Well, they still point to the same thing. Okay, so we're going to have my int is also going to point to 25 when we come in here. They both point to 25. Okay, and then we're going to change, but we're going to have our own little copy of it here. And we can do whatever we want to, destroy it, change it, or whatever. And you know what? This original variable up here is still going to point to the 25. So let's run this as a test and demonstrate that. Okay, so let's see what that looks like. So we came in here, we assigned the value 25, then we called the subfunction. It says enter subfunction. Okay, we're in there. My int value is 25. Great. We change it to 99. Then the terminal my int value is 99. We leave the subfunction. That's great. Now we return up here and we say the original value is original int. Yeah, it's still 25. It's 25 because we got a copy of the reference to that bit 25, and when we change the value, we call our parameter name down here to point to a new value. It's pointing to a new object 99, but this variable up in main is still pointing to the original object. Okay, so it's not possible for called code to take any parameter value that is passed to it, any actual parameter that refers to an immutable object, okay, and to change it such that there's what's known in the calling code has now been changed. Just not possible to do. Okay? So I'm going to have you do this kind of same thing for another type. Okay? The three types that we know that are immutable so far are ints, floats, and strings. So it might be one, it might be the other. You'll have to read the instructions. So good luck on that, and I'll see you next time.